Hello and welcome back. In the last few videos we went over the idea of what a function is. So we talked about how a function is essentially a machine that takes in an input, does something with that input and produces an output. Then we went over a few concepts including domain and range and graphing. So now we're going to go over the different types of functions. In this playlist, the function that we're going to be going over is the linear function. So we'll start off by explaining what exactly a linear function is. So with a linear function, you're allowed to do 4 different things to x. You're allowed to add to x, subtract, multiply, and divide. So let me show you what I mean. So we can create this function over here, y is x plus 3. That's a linear function because we're adding 3. That's okay. We could create another function that subtracts 2 from x. Again, that's fine, we're just subtracting. We could create another function that multiplies x by 5 and another one that divides x by 4. Those functions are fine because they're multiplying by x, we're dividing x by a number. As long as we're just using those 4 operations, we're good. And we don't just have to use only one of those operations. We could use 2 or more of them at the same time. So for example, y is 5x plus 12 was okay. We're multiplying x by 5 and adding 12. So we're using operations of addition and multiplication. We could create another one such as y is x divided by 5 plus 2. That's fine because we're simply dividing x by a number and then adding 2. And we could also create a function here, y is negative 3x plus 8. That is also okay because we're just multiplying x by negative 3 and adding 8. So as long as we make a point of sticking to those 4 operations, we're good. Alright, then I'll go over some examples of functions that are not linear. So y is equal to x squared plus 3 is not linear because we did something else here. We used 2 as an exponent. We're squaring x, and that is not allowed. We could create y is 3 to the x. Again, here we're using x as an exponent, and that is not allowed. So we can't have any kind of exponents, otherwise it will not be a linear function. And finally, we can have y is 1 over x. That is also not a linear function. We can divide x by a number, but we can't divide a number by x. So it's okay to have x in the numerator, but we cannot have x in the denominator. Alright. Next thing we're going to do is go over some graphing. So why don't we create our own function over here? Y is 2x plus 1. We know this function is okay because we're just multiplying by 2 and adding 1. We're sticking to that 4 operation rule. And we know that we can test for different inputs and therefore create different coordinates. So for x is equal to 1, we plug that in, we get y is 2 times 1 plus 1, that gives us y is 3. So for x is equal to 1, y is equal to 3. And we could write that as a coordinate pair 1, 3. We then look over to our graph, we look for 1 on the x-axis, we mark that with an indent. We look for 3 on the y-axis, we mark that with an indent, and then we trace that over to a point and plot that point. And then if we want to plot multiple points, what it might be helpful to do sometimes is to create a table with x and y. So we already have one coordinate, 1, 3. So we can put that in our table. You know that for x is equal to 1, y is equal to 3. We could try x is equal to 0. We know that if we use x is equal to 0, we'll have y is 2 times 0 plus 1, and thus y is equal to 1. So for x is equal to 0, y is equal to 1. We could once again plot that, so we could look for 0 on the x-axis and 1 on the y-axis and plot that point. And we can do this a whole bunch more times for different coordinates, using different x values to get different y values. So you can test to see for yourself that if we plug those other three x values into the function, we get those y values, and then we plot the coordinate. So for -2, 3, we plot that point. For -1, -1, we can plot that point, and for 2, 5, we can plot that point. Alright, so that's good. We have a whole bunch of points on the graph. Now, as we did in the last video on graphing, we can connect the points and form a line. And now we have just explained why a linear function is called a linear function, because its graph produces a line. Alright, so now we have our graph, we have our function, and I want to go over some important terms that you're going to come across a lot when dealing with linear functions. So those two terms are slope and y-intercept. Okay, so whenever you have a linear function in that form, for now you can think of it as the number in front of the x is the slope, and the number that comes after x is the y-intercept. So what do these terms mean? Well, the y-intercept is referring to the point at which the line intercepts the y-axis. So when we look at our graph over here, we notice that the line intercepts the y-axis at y is equal to 1. So therefore the y-intercept is 1. Looking back at our equation, we know that the value that we labeled as the y-intercept is also 1. So that is good. The other thing is the slope. So slope is rise over run. So what exactly does that mean? Well, let's look at our graph over here, and let's just sketch a triangle that connects two of the points. So we notice that the height of this triangle is 2, so I can label that as 2, and the base of this triangle is 1, so that is 1. So how is this related to a rise over run? Well, rise, we know that rise is vertical. When you rise, you go up. Now we also know that y is vertical because y refers to going up and down. So rise refers to the amount by which y increases in this case. So we look at the triangle, we notice that y increases by 2. Therefore, the rise is 2. Run, so when you run, you're moving to the right or to the left. And same idea with x. X moves to the right or to the left. So run refers to the amount by which x changes. In this case, when you look at our triangle, we notice that x increases by 1. Therefore, the run is 1. And then 2 over 1 is 2. So we've established that the slope is 2. And we notice that this value is the same value as the value that we labeled on our equation above. We labeled 2 as a slope, and that's the value that we got over here. So slope is basically asking, when x increases by this amount, how much does y increase? In this case, when you look at the graph, we notice that when x increases by 1, y increases by 2. The other thing I want to point out is that we didn't have to pick those 2 points necessarily to do the slope calculation. We could have picked any 2 points on the graph. So for example, we could have picked those 2 points to draw the triangle, find 2 and 1, and compute the slope. We didn't even have to choose a triangle of the same size. So for example, we could have picked the point at the far left and the point in the middle, and that would have given us a triangle with a height of 4 and a base of 2. But you notice that when we do the slope calculation, in this case our rise is 4 because y increases by 4, and our run is 2 because x increases by 2. 4 divided by 2 is still 2. So even though we had different values for rise and run, we still got the same answer. Which means that it doesn't matter what 2 points you pick, you will always get the same slope calculation as long as you do it correctly. So that's all I wanted to say for this video. In the next video we'll do more calculations and go over more concepts involving slope. But for now, thanks for watching.